Hello, I'm W.P. Suazo, and today's topic is fiscal action in GDP. Now, I will begin by explaining what I have written at the top of the board here. What we have is, what will government action, change in policy, do to the economy, to GDP? So, the first thing you may do is look at the change of GDP being described by cumulative. What is the cumulative change to GDP? So, the government changes something, be it government purchases, taxes, or transfers, that has an initial impact that is described in cycle one. So let's say the government builds a new school that costs $100 million. So we ask ourselves, by building out a brand new $100 million school, what will be the cumulative impact to the economy, to GDP? Another piece of information we have here in the given pieces of information I put in boxes is 0.2. So this says NPS of 0.2. In this economy, people are saving 20% of their income. If they save 20% of their income, that means they spend 80% of their income. Okay, 80%. So, if their marginal propensity to save is 0.20, their marginal propensity to consume is 0.80. Both have to add up to 100%. If we take 100 million and plug it in again, we have 100 times 0.8, or 80% of 100 is 80. So if we have a brand new school being built that has a budget of 100 million to construct this brand new school, the initial impact is 100 million in income. The cycle 2 impact will be 80 million. Now, if we are saving 20%, our multiplier, this says multiple. It says multiple because there are numerous multipliers. Our first multiplier that is used for the government purchases multiplier would be the inverse of that 0.2. So the inverse of 0.2 is just another way of saying 5. So if we build a brand new school in an economy where people save 20% of their income, this is going to be initial cycle 1 impact of 100 million times 5, which will have a cumulative impact of 500 million. Okay. Let's say that this new school is canceled. It's not built. And instead, some other politicians say, why don't we cut taxes by $100 million, or why don't we increase government transfers by 100 million? If that is done, then we must use what is called the T multiplier. Because transfers and taxes impact not only spending but also savings, they have a weaker effect. And we weaken the T multiplier by putting MPS under MPC. So the T multiplier, which applies to transfers and taxes, hence T multiplier, is articulated by putting 0.2 under 0.8. So now we don't have 5, we have 4. So instead of building a $100 million brand new school, let's increase transfer or welfare payments by 100 million, and that will expand the economy by 400 million. Now, one other thing we have to do is we have to say, well, unlike paychecks to construction companies and construction workers, some transfers, some portion of transfers are saved. Some portion of Social Security checks are saved. So we first have to discount it by 0.8, and then we apply 0.8 again. So the cycle 2 impact will be 64. And if 0.80 is our MPC, 0.20 is our NPS. Okay. So that is our first example right there with some popular numbers. 100 being a popular number and 0.80 for an MPC. Here's our second example here, which tells us that the multiplier, which is our first multiple, is 4. Well, If the multiplier is 4, then the MPS is 1 over 4, which is another way of saying 0.25. If this economy is saving 25%, it's spending 75%. All right? And then we have to ask ourselves, what times 4 equals 960? That's almost 1,000, so this is going to be 240. So I say to myself, what times 4 equals 960? So this is 240. So now we know cycle 1 is 240. Cycle 1 is 240. Okay, what will be the impact in cycle 2? Well, 240 times 0.75, 240 times 0.75 gives us 180. So here we have 180 for our cycle 2 impacts, and voila, it's done. So to recap, once we know that the multiplier is 4, the MPS is 1/4. If people are saving 1/4, they're spending 3/4. Then we say, what times 4 equals 960? 240 is the missing cycle 1. We plug it in, and 75% of 240 is 180. Now, if this 4 comes from this, is the result of this calculation, then we know the T multiplier has to be 3 because it will come from this. So there's our T multiplier being the 3. And we could say, the MPC is 0.75, and the MPS is still 0.25, but now we have a 3 here. Okay, so instead of increasing spending by 240, if we were to, say, cut taxes or increase transfers by 240, that result would only have, this action would only have a cumulative result by times 3. And as you know, 3 times 200 is 600 plus 120. We'll have a result here of 720. That'll be, so 3 times 200 is 600, 3 times 40 is 120, 120 and 600 is 720. So the T multiplier is weaker and has a smaller result. So looking at 240 here, what we have to do is, well, if these are transfers, people are only going to spend 75% of any new monies they get, any new incomes, because they save 25%, and then 75% of that is spent. So this cycle 1 impact will be weaker at 135. Okay, so there's our second example done. Now for our last final example, I thought it would be apropos to use negative values. So here is a scenario where we are going to spend 200 in cycle 1 and then 180 in cycle 2. You can divide 180 by 200, and what you'll find is 0.9. 0.9. I could go ahead. I didn't wind up using as much space as I thought I'd use, so I'm just going to move these up here, and I will put them in boxes. Putting them in boxes indicates that this is the information we're starting with. So if we start only with these two here, we say, all right, 180 is 90% of 200, which is simply the result of dividing 180 by 200. So we have that there. If we are MPC spending 90, we're saving 0.10. If we're saving 10% of our income, then we know that our first multiplier up here applied to government purchases is 10. So let me put in a comma. So if we have, say, a public facility that has a yearly operating budget of 200 million, and we close it could be a military base, it could be a public works depot, whatnot. What will be the final or cumulative impact to the community? It will be negative 2,000. Now let's say we have a transfer program that has a budget of 200 million, and we are canceling that. Well, to find cycle 2, we have to first multiply it by 0.90 and then 0.90, because people weren't spending all of their transfers. Maybe that doesn't sound realistic, but according to theory, individuals don't. And if you think about it, some portion of Social Security checks are saved. So we're going to save 10%, so we're only going to subject 200% to our, we're only going to subject 90% of the 200 to our spending habits. And then we only spend 90, so it's 0.9 times 0.9 there. So that result being negative 162. So if we have a transfer program with a budget of 200 million and we eliminate it, in cycle 2, the impact felt will be negative 162. If we're spending 0.90, that's not negative 90, it's 0.90. Then we are saving 10%. If we look over here, we're going to have 0.10 over 0.9, which makes for a multiplier of 9. And the cumulative impact to the economy will be negative 1,800. So here are 3 examples with the given information in boxes. I hope this helps your understanding of what multipliers are applied to different changes in government policies. And thanks for watching.